Welcome, or hopefully welcome back to another episode of the Reliability Matters podcast. For those of you who are counting, this is episode number 152. As the demand for more durable and dependable electronics continues to rise across industries, the choice of soldering materials such as solder paste plays a pivotal role in determining the reliability of these devices. In this episode, we'll discuss how selecting the right solder paste can influence performance and reliability, and we'll hear from an industry expert about the latest advancements and best practices in solder material technology. My guest today is Ebad Rehman, Regional Product Manager at MacDermid Alpha Electronics Solutions. He has a master's degree in technology from Illinois State University and has led multiple technical and strategic projects for MacDermid Alpha, including new product development and technology development projects using lean and agile methodologies. He's also planned and developed processes for the Power Electronics Group and the Aftermarket Enhancement Group to drive efficiencies and effectiveness. So, whether you're a seasoned engineer or someone new to the electronics industry, this episode will equip you with the knowledge to make informed decisions that enhance the reliability of your electronic assemblies. Join us as we explore the critical intersection of material science and electronics reliability. And we'll do that when I return in just a moment.
Welcome to Reliability Matters, a podcast for the electronic assembly industry. Each episode covers topics related to reliability, best practices, and environmentally responsible assembly techniques, with insights from experts across the electronic assembly industry. Now, here's your host, Mike Konrad.
Ebad, welcome to the program. I'm glad you're my guest today.
Thank you, Mike. Thank you for having me, and it's nice being here.
Yeah, I'm glad you're here. Want to talk about solder paste?
That's what we do every day, Mike. So let's get started with that.
Let's get started with that. Remind me, I may have said it in the intro, but I recorded the intro a couple of days ago, so I don't remember. How long have you been in the world of solder paste and soldering materials in general?
So, Mike, I've been with MacDermid Alpha for 4 years now, but in the past, I've been very much engaged with the electronics itself. In fact, my background is EE, so I'm very much into during my student time. I've been very much engaged with hand soldering and all those practices.
Yeah. Okay. So good. So you've seen some changes over the last several years, or since you've first stepped foot into this crazy world of electronic manufacturing. You've seen some changes. What, in your view, what have you experienced the industry changes when it comes to solder paste or soldering materials in general, since that you've been able to witness or that you've heard of? What are some of the major changes up to this point that we've experienced?
Mike, I think the biggest change which we have seen in the last 2 decades is a mass transition from leaded solder to the lead-free solder, and I think that's the biggest thing which we have witnessed so far, and a continuous push towards getting to the lead-free solder paste, even for the applications which are heavily focused using leaded solder paste. But one thing which has really caught my attention and really amazes me as what has happened in last 5 to 10 years, which is a adoption of higher reliability solder paste in solutions. And that's primarily due to the applications in the automotive industry. And as we see this trend going forward, we are seeing more demand for very challenging applications, which requires soldering. For example, your finer pitches components. We are talking about micro BGAs now. We are talking about very miniaturized components. And at the same time, we are also looking at some very high reliability stuff in context of the advent of AI and advancement of automotive applications such as your advanced ADAS. So, Mike, it's like a fine balance between these two extremes. But again, there has been a lot which has changed. And I think for us as a material supplier, we work with our customers and to understand how these changes are coming their way and how these things are evolving, and that really helps us to stay competitive in the market. And again, all the material suppliers, I believe, in the market right now, they are very close to the challenges for what electronics industry is facing right now and what we foresee in the future.
I've always found it curious when solder materials companies talk about their high reliability solder paste, because I never hear any company talk about their low reliability solder paste, right? I mean, I'd assume everything everyone sells is high reliability, but obviously within our world, within the electronics manufacturing world, there are definitely various expectations of reliability. No one assumes low reliability. No one strives for low reliability. Everyone strives for reliability. And then there are those applications where if products fail, people die. That's extra reliability. So reliability means different things to different people. We're an equipment manufacturer, and I would like to think that all of our equipment is built to high reliability standards. But then again, death and destruction aren't the repercussions if one of our pieces of equipment fail. So clearly, the folks that are making class 3 or space level electronics they're definitely high reliability. But what does high reliability mean to you? You mentioned automotive. So automotive, yeah, clear. I want that to be reliable. I want my medical equipment to be reliable. I want my military equipment, communications to be reliable. But I kind of want my remote control, my Apple TV to be reliable too, just from a convenience standpoint. So what does reliability mean to you? What does it mean to MacDermid Alpha? What does it mean to our industry from your experience?
Well, Mike, I think you did sum it up in a really good way. That reliability could mean different. It could be a different thing for different people and different market segments. In fact, in the same organization, two people could have different definition of reliability. But when we talk about solder paste technology, when we talk about the world of soldering, by high reliability, we are meaning any material which can withstand the harsh environment. We are talking about high temperature operation. We are talking about operation in high humidity. So that is something which we have in our minds from the soldering perspective. And as of now, I think you're right. In fact, all of the soldering manufacturers, they have their version of a high reliability material, which is again to support the industry in general to attain the level of reliability which we are targeting, especially in safety critical applications, especially in your ruggedized application where there is no propensity to fail. And again, as I mentioned, if we draw a comparison here, so we want something which is beyond an industry adapted SAC based alloy, something which can withstand the stress for a lengthened amount of time. And if you look about the materials, Mike, let's talk about the better way to understand it is looking at the plastic and elastic zones. So all of the materials at certain strain levels, they're malleable, so which means they can come back to their original condition once you remove the strain. But the problem starts when you're putting a continuous strain and you're asking the material to go back and forth within that range. So the question is your material robust enough to withstand that back and forth of maybe thermomechanical strain, and would it be when would it fail? So the idea, if we take a step back and look at the idea of high reliability, whether we talk about telecommunications or safety critical devices, and again, this could be different solutions, but the overall idea for the high reliability stays the same. And that is making sure you are extending your in-use life of that particular assembly or your system. And Mike, again, here at MacDermid Alpha, we do have some solutions which can really help for applications in different market segments to attain those reliability goals.
Excellent. For high reliability applications, we generally IPC classifies those as class 3, right? That would be aerospace and military hardware and things like that. And then we have class 2, and then we have class 1. Class 1 being just consumer stuff, video games and remote controls, and for televisions and things like that. There's a blurred line, and I've talked about this on this show before. There's a blurred line now because of Internet of Things, IoT, and just the general explosion of electronics. More and more traditionally class 1 devices, kind of lower quality, if you will, or lower expectations of quality, are making their way into the moist, cruel world out there, and that's creating some reliability issues with typically lower quality or lower expected quality devices. So many times manufacturers of lower end materials or products are having to up their quality game just so they work. No one dies if they fail, but except maybe their company's reputation. So we're seeing more higher reliability expectations in class 1 and class 2 devices, always there in class 3. Besides the general level of reliability expectations, if I'm going to fly in an airplane, I want that to be reliable. I expect it. I demand it to be reliable. Besides the expectations of reliability, what are some of the environmental factors that and the in-use factors that could steer someone to select materials that are specifically designed for high reliability? So I'm looking to build a widget. It's not going to be a class 3. It's going to be a class 1 device. And I'm looking at your catalog of solder pastes. And this device is going to be a wearable. It's going outside. And it's designed to be used on a winter jacket for the snow, for skiers. And so it's going to be exposed to some pretty harsh, humid, or not humid, but moist environments. What are these elements? What are these physical elements and environmental factors that would drive me toward the high reliability side of the product selection chart versus the standard side of the product selection chart? Does that make sense?
Right. Yep. So Mike, again, as we talked about reliability, it could mean different things to different people. Primarily, when we talk about reliability, we are referring to the thermomechanical reliability, but that's not the only reliability you want in your system or on your board level. You're also looking for something which is electrochemical reliability, and especially when we are talking about, in this case, a widget, a wearable, and we are seeing a heavy trend of miniaturization, making things smaller, which requires lesser real estate, if you will, in the real world for these kind of widgets. So we are seeing the component size shrinking. And in those kind of scenarios, I think the right kind of reliability which you're looking for would be your electrochemical reliability, because finer pitches could trigger your electrochemical failures. It could impact the longevity of your use. And if you're having any ionic migration issues on your assembly, that could cause a short. So I think, again, it depends on the application, Mike, what in the end, what you're trying to achieve, in what ways you're trying to be reliable. Again, as I said, reliability is different things to different people and different organizations, but understand one thing, that every company which is making or producing electronics right now, the end goal is for them to make their products reliable and extend their in-use life. So that could be attained by improving your thermomechanical reliability, or also by using the right flux chemistry or right solutions. Perhaps it could be your conformal coating to enhance your electrochemical reliability.
I'm glad you said electrochemical reliability, because that is quite literally the next question on my list. So we're thinking in the same genre here. In my field of specialty, I'm all about electrochemical reliability, right? That's what, in the cleaning world, that's what we try and fix up. We try and remove all the stuff left behind from the reflow process to avoid ECM, electrochemical migration. So from an electrochemical reliability standpoint, first, for the sake of my audience, describe what electrochemical reliability is. And then we'll kind of morph over to, when it comes to solder paste chemistry, what makes the chemistry electrochemically reliable? What's the difference between an electrochemically unreliable chemistry and a reliable chemistry? But let's start with the definition of electrochemical reliability.
So, Mike, I think that's a really good question, and I was expecting that question as well. And it's great because I think one of the challenges which we face as of now in the modern day electronics is electrochemical reliability, and that's solely because of the nature of designs we are having. And just for the audience to understand the idea of electrochemical reliability, it's regarding it's in simplified words, you're trying to avoid any ionic migration between your anode and your cathode, and those kind of ionic migrations can cause a short, which can lead to an ultimate failure in your assembly. Again, as we see that the assemblies overall are getting really complex in designs, the sizes of the packages are shrinking, and we are seeing more and more functionality is being built onto the boards as of now, especially when we talk about the next generation driving systems or the safety critical devices. You're putting so much functionality into it that the real estate is literally you have no space on the board. So the idea is to make sure that once you have reflowed the board and you have all the components on your board, is to make sure that the electrochemical integrity of that board is still there. And how we do it, we design and first of all, Mike, let me take a step back. We could have multiple approaches to it. We could clean, we could definitely clean the board. And as Mike, you said, for applications where there's no propensity to fail, and even 1% or maybe 0.1% of residue could trigger a failure.
And just to be clear, sorry to interrupt, but just to be clear for my audience and me, when we're talking about electrochemical reliability, we're referring to no clean solder paste, where the intention is not to clean it. Because if we're cleaning, it doesn't matter, right? It doesn't. We don't worry about electrochemical reliability because we're removing all of the bad actors, the activators and ionic contamination. So we're talking about electrochemical reliability of no clean solder paste when the user has no intention of cleaning after, right?
Right, Mike. Right. So if you are having a no clean chemistry, Mike, I think those chemistries are designed to, first of all, to increase your throughput, because now you don't have to clean. Secondly, to increase your to ensure that even the residue which is left on the board post reflow, it's not active enough. So what we do, we design the chemistry in a way that the corrosive residue is encapsulated, which means it's not going to cause any negative impact on your assembly in the long run. But again, it comes down to the chemistry, Mike. Choosing the right chemistry could be really crucial, because in some cases we see that a chemistry which is really good for a normal application could not be applicable for a modern application. For example, when we're talking about finer pitches, when we're talking about your area under the BTC or your bottom terminate components, that could fail. So again, it comes down to the chemistry, and choosing the right chemistry is the key.
So let's switch gears from electrochemical reliability to something a little bit more physical, and that would be the solder sphere size, the actual size of the little solder balls, the spheres that are in there. I believe in your world that those are defined as types, right? So there's a type 1 or a type 7 or a type whatever. For the sake of my audience who's not in the soldering materials world, what do the type designations stand for, and what are the advantages or disadvantages of the various solder types, like type 3 versus type 7 or whatever the case may be? What would drive someone to select one type over another?
Mike, I think that's a really good question to understand how the powder or the particle size works in the solder paste. Generally speaking, for the SMT applications, we have type 3, type 4, and we are now seeing a good traction in type 5 and type 6 as well, based on the miniaturization of your assemblies, especially those small medical devices, or even some of your automotive assemblies are moving to the type 6 powder. But when we talk about type 7 and type 8, that's we are pushing now into the semiconductor space and not the SMT. But
okay, so the higher the number, the smaller the powder size. Or
the smaller the powder size.
The particulate,
yes, yeah. The smaller the powder size. And again, the idea is having a decreasing particle size as we move the higher. So you're correct on that. But the idea is the biggest thing, or an advantage to having a finer particle, is now you are able to get the more consistent target volume for your solder deposit, and that could be very critical for some modern day assemblies. But there is a downside to that as well. Now you're talking about more surface area you have to cover as you move to this finer particle size, which could expose you to the risk of oxidation, and that can impact your solderability. So in case of the finer powder, Mike, what we did, we designed a specific chemistry which is robust enough to handle those kind of finer powder or finer spheres, and it does not impact your solderability. Because again, Mike, as I mentioned in previously as well, the idea is to make sure that every solution which we are developing for our customers or for the broader industry, it's application driven, and we have an answer to the challenge which our industry is facing right now.
Yeah. So is it mainly pitch size, component size, maybe density that drives to a higher type number? I think it's both. It could be your component size, and it is the pitch as well. And the aperture size, obviously, and the aperture size of the stencil, right?
For example, Mike, if we talk about type 4, let's say, normally for a type 4, the area ratio which we are targeting is around 0.65 and 0.66, and anything above that, type 4 powder should be able to print it. But when we talk about type 5, we are now getting lower on the area ratio size. We're talking about something between 0.55 area ratio and 0.64 area ratios. And once we move to type 6, now we are at very finer pitch. We are talking about 0.5. And if we talk about the components, we are talking about 008, 004 chip resistors, something in that range.
So what's the highest type number in use right now?
For the SMT applications, Mike, we are having type 6, which we are seeing a gradual transition. But at the same time, I think the next thing for what we are seeing it could be a big demand is type 5.
Interesting. Are we ever going to get to a type 27? I mean, is it going to get so small that it's on a molecular level at some point, or are we going to have are we going to max out?
That could be a nanotechnology, and I think at that point we have to think about some other solutions for
soldering. We're not using stencils for that,
for sure.
At least not the way we know it. Let's switch gears and talk about environmental for a moment. With many corporations embracing ESG programs, for those who aren't aware, environmental, social, and governance, how is your industry addressing environmental concerns that are related to soldering materials? I remember not too long ago, you and I probably both remember not too long ago when solder was, tin and lead, right? Lead being the offending term. Now we've taken lead out, but there's still metals in there. There's still chemicals in there. And not only that, we change their state. We go from solid to liquidus and back to solid, and we create fumes, and there's fume extractors, and there's all these things, all these potential environmental buttons that could be pressed. What is your industry doing to mitigate that, or to just reduce an environmental impact, to make corporations with ESG programs be able to check the box, when it comes to soldering materials?
Mike, in general, from a very high level view, I think that the compliance and the regulatory issues for anything, especially now, has been really picking up or getting some more attention now. And one thing to mention here, that most of in fact, all of the startup-based chemistries which we have right now are RoHS and REACH compliant, and that's the basic need which not only MacDermid Alpha is being compliant to, but I think all the material suppliers have to. Otherwise, there are certain parts in the world we cannot sell our materials. But in general, when we talk about our ESG or our kind of circular economy, Mike, I think MacDermid Alpha, we have partnered with our customers to ensure that we can be we can be hands in hand with them in order to achieve their sustainability goal. And again, Mike, we all have to play a role in that. We have a product in our portfolio which is a more than 90% recycled tin. And what we have seen, Mike, that even with the recycled material, there is no impact on the product performance, which means you're getting the same amount of performance which you're getting from a virgin material. But the upside to that is, Mike, now you are getting some points on your ESG reports. And again,
check.
The biggest, exactly. And Mike, one of the biggest push which we are seeing right now, and that could be later in the Americas as well, is Europe, because we have a mandatory ESG reporting starting in 2025. And I think that could have a big impact on this whole idea of circular economy and how we can make sure that the materials which we are using are sustainable, first of all, and they're derived from sustainable sources, and how are they impacting our future for the coming generations.
That's a good answer. And it is important for companies to, if they don't even have a formal ESG, that tends to be Fortune 500 type companies that tend to embrace, the formal programs like that. But I've long said there are two reasons. There are two greens to chase, right? People seek green for two reasons. One green is money, cash. The other green is in the environment, and probably not in every application, but certainly in many, you can get both greens. In our world, in the cleaning world, if we go zero discharge, which is as green as one can get in that context, it's actually a little cheaper to run in the big picture than discharging things down the drain, getting permits and all that stuff. So I'm like, I don't care which green you chase money, chase either way. You can kill two birds with one stone,
right?
And by just going zero discharge. In your world, it might be choosing recycled tin, or whatever the case may be, but you get to check that box and make a small difference in the world.
Mike, I think it's more than yeah, you're right. It's checking a box, but again, if you look at a bigger picture, it comes down to what we are leaving behind. And
Sure.
I think most of the companies, especially like us who deals in who works with chemicals and any mishandling of those kind of materials could have a devastating impact on the environment. So we just have to be responsible about that.
Right. Let's go back to solder paste selection. What are the key performance metrics that are crucial for solder pastes that are used in safety critical applications? That falls along the same line as high reliability. But what are the metrics that someone should look for other than a label that says high reliability solder paste? What differentiates a regular solder paste from something that would be more suitably used in a super safety critical, mission can't fail type application?
Mike, there are a couple of things which we have to look at when we are choosing the solder paste for the high reliability application. And one thing which we have to be mindful about, as you said, the right choice is the key because there is no propensity to fail. We have seen in the past that there could be some adverse implications if something fails, especially in your car. It could be a liability or a big liability. So I think that the biggest two metrics which I see it as the thermomechanical reliability and your electrochemical reliability. And again, if you break it down, Mike, it's pretty simple. Your thermomechanical reliability is a derivative of your alloy which you're using, which is making sure that you're not having any premature failures, which is ensuring that you have a longevity in your in-use life. And on the other side, you have your electrochemical reliability, which is ensuring that even with the high density boards, you're not seeing any shorts, you're not seeing any electrochemical migration on your board. So I think those are the two things, and we can further break it down. Like you can look at some thermal cycling performance of the alloy. You can look at the vibration, how does it perform to continuous vibration environment, or in fact, a drop shock could be one of the indicators for some of the applications. But in general, I think those are on the high level, those are the two things we have to look at to make sure that when the choice we are making for the high reliability solder paste, it is the right choice.
Yeah, that makes a lot of sense. What are some of the main challenges and limitations of solder materials that are currently available today in meeting the requirements of future trends? Where's the temporary end of the road in terms of capabilities, and what roads need to be extended, to continue that metaphor, to meet the future trends? Well,
Mike, first of all, I hope there is no end to this road.
But there never is. No, there never is.
But generally speaking, Mike, if we take a step back and just look at the trends, what's happening in the electronics industry right now, and we break it down. Let's take an example of automotive. I think most of the OEMs right now are racing towards the high level of autonomy. We are talking about level 3 plus, level 2 plus for the ADAS levels. We are talking about the modern architecture in your vehicle, which is a domain architecture, and then in the future we are talking about zonal architectures. And if we look on the other side, there is an advent happening right now in our lives, which is AI. It's taking over everything. And if you look at in a long term, your car would also be driven by AI. So you would be driving an intelligent car in the future, which means there's a lot of compute happening within your car. And while it actually communicates back and forth with the city grid, perhaps, or with your pedestrians walking on the road, or even car-to-car communication, you have to make a decision in a split of a second with very ultra-low latency. So if we look at those trends, Mike, I think the biggest thing which can happen is the amount of thermomechanical strain we are putting onto these solder joints. And we do have some existing solutions which are performing so far. But if we look far out, that's where we see the challenge, that the amount, if if we look at the Moore's law right now, Mike, we are diverging from the Moore's law. So every year, your computing power or processing power is increasing by 8 times, which is significant. And again, the amount of data transmission you're talking about is maybe a couple of billion transistors working at the same time on a system or a small system on chip, with trillion teraflops operations per second. So taking all that into account, Mike, I think the biggest thing which we have to resolve for the future electronics is the thermomechanical reliability, and also to some extent your electrochemical reliability.
Excellent. How important is industry collaboration and standardization in advancing solder paste technology? We are in a, I don't know if our industry is unique. It seems unique to me that when I go to conferences, we're very collaborative. You know, there are many competitors, yet there's also quite a bit of collaboration. You know, we're all in the same pond, right? We're all swimming in the same pond, and the sharks, a pond might not be a good analogy because there's usually not a shark in a pond, but we're all swimming in the same sea, and we're all avoiding the same sharks, right? And trying to get to the same destination. So we're all in it together. So there does seem to be, from my perspective, an unusual amount of collaboration. So how important is that industry collaboration and the standardization in just advancing any technology, but particularly solder paste technology?
Mike, as we see the technology advancing and the designs getting more complex, the biggest challenge which we see revolves around your first of all, again, your design, your processability, and also the validation of these new modern electronics, because these are the things which no one has even imagined like 10 years ago, which we are seeing right now. So I think in general, the industry is aligned in terms of the standardization and covers most of those parts. But there could be some unique challenges where companies like us, we can jump in, we can help our customers overcome those challenges. But again, on a very high level, if we talk about the industry, are the bodies which govern the standards in our industry, such as your IPC, your SMTA, or your AEC, they have done a good job in standardizing the thing. But as we see the future, the challenges which lie ahead of us, I think it would be again a good collaboration between the industry and even competitors. Mike, take an example. We have a living example of one of the alloys, Inolot, which is synonymous to high reliability. And if we look at the history of that alloy, it wasn't just MacDermid Alpha. It was our competitor, 3 material competitors sitting together with some OEMs, with some some tier ones, and coming up with the alloy because we had a challenge at that time. So I think our industry is very welcoming and very embracing in that way. It's, even with the competitors we have, we are marching towards solving the same challenges one way or the other. So coming together for these kind of challenges and sitting at the same place talking about it, it could really help us align for the future challenges which lie ahead of us.
So what are some of the common mistakes that you see when people reach out to buy a solder paste material or a soldering material in general? What do you see people do that you wish they wouldn't do? You kind of have to retrain them. You know, is it going straight to the price list? Is it something else? Is it buying the wrong type? Is it what things do you see that you kind of routinely have to retrain the consumer to not do that way? What kind of represents worst practice versus best practice in buying habits or selection habits?
Like, I think it's a combination of things, but couple of things which stand out, and what I can think of right now is not knowing your application. People, again, the application you're working on, you have designed it, but at the same time, the material challenges could be different, and that's why a global company like MAES we can help our customers with those things. We can partner with them for not only the selection of right material, but also optimizing the process, because different applications, different designs might require a tweak in the process, and that's what we are here for. The other thing could be, Mike, know what you're buying. First, like, I think you mentioned it, the price list. I think the price list is for, let's break it down. Starter paste is the least expensive material on your board assembly. So, but if a couple of cents can provide you a higher reliability and can excuse you from getting some warranty claims, why not go for it? So I think that's a mindset we have to develop in our consumer, that yes, the existing solutions which we have for the higher reliability or increasing the board level reliability are great, but we should be changing our approach now, because I think if we sum this whole discussion up, Mike, we were talking about next generation, the modern electronics, and that's evolving. So you cannot expect a legacy material or a legacy approach to be catering the trends in the future. So I think that is something which we need to understand as an industry, or also for our consumers, that be open to the new approaches in resolving these these design or new high reliability challenges in the modern day electronics.
So, final question, Ebad. Let's advance time. Let's go forward in the future. You're now 67, 68 years old. You're ready to retire. Your hair's all gray. You're part of the silver tsunami of people retiring from our industry. What advice would you give to manufacturers and engineers who are looking to adopt next generation solder paste? So they're taking over from where you left off. As you go out the door, holding your, golden cufflinks and all that, and you look back at the engineers, what would you tell them to seek, and what guidance would you give them for the next generation of applications?
I think, Mike, that's very far out, but
it
is a really good question, I would say. And first thing could be know your application. I think that's what I said in my last answer as well. But know your application. What are you trying to achieve? What is your end goal? What is the end post? Is it your, and what challenges are you facing? Identify the pain point so we can work on that. Mike, the how the industry is moving right now, and the amount of challenges which we face with these electronics assemblies, there could be no silver bullet so far for all those challenges. So identify the pain point and try to solve that first. And secondly, find a global supplier who can help you not only with supplying the material, but also can help you develop the process, and be open to change again, Mike. Be open to change. If one approach doesn't work, there could be a different approach of resolving a same challenge, but ultimately the goal remains the same: increase the reliability of your electronics assembly. And I think that's the target for that is the target right now, and that would be the target in the future as well.
Yeah, I think you hit it hit the nail on the head when you said, be open to change. You cannot be in this industry for more than a few years if you are resistant to change, right? I started in this industry in 1985, so that's 39 years ago as of right now. And oh my gosh, the number of changes that I've witnessed that I've probably forgotten half the changes by now, but it's a constantly evolving field. And
right.
There's evolution, there's revolution, there's all those things within our industry, and one has to stay on their toes. And just when you master something, the next generation comes out.
Yep.
Right. And our industry is quite interesting in that as an example, the component designers, they'll come up with a new footprint of a component. They'll come up with a BGA. I remember when BGAs came out. So here, industry, here's a new package. Awesome. how do we solder it?
Don't
know, not our problem. You guys figure it out. And then we spend the next 10 years in technical conferences and symposiums, trying to teach how best to mount it to a board. And then the next question is, well, how do we inspect it? And it's like, oh,
right, your
problem, pass the torch, and then eventually we get it down, it becomes mainstream. And then the next, the next QFN comes out, right? It's like,
right.
How do we mount this? How do we inspect this? How do we clean under this? How do we do all these things? And then the industry evolves, and then something else comes out. So I'm sure the same is the exact case for soldering materials.
Exactly, Mike. Exactly.
You come up with a new material that hits all the environmental standards, and then the next question is, how do we use it? What's the right profile? What's the this or that? So. Yeah, none of us are going to be out of a job due to lack of need anyway.
Let's put it this way: there are plenty of challenges still which need to be solved on the electronics assembly as we move forward. We have attained so much, but there's still a lot to be achieved.
Yeah. No one's closing the door, turning off the light, and saying all challenges have been solved. Yeah,
right.
The next generation, you've got plenty of work to do.
Right.
Well, Ebad Rehman, thank you so much for being my guest today. This has been exceptionally informational and informative, and I appreciate you sharing your advice and your knowledge and your wisdom with me and my audience.
Thank you, Mike, for having me, and pleasure to be here.
My pleasure as well. Well, that's another episode. Thanks for listening to or watching the Reliability Matters podcast. Don't miss an episode. Subscribe to Reliability Matters on your favorite podcast app. If you're watching this podcast on the Reliability Matters YouTube channel, be sure to click the like, subscribe, and bell icons to be notified when new episodes are released. We release new episodes on the second and fourth Tuesday of every month. A special thanks to Printed Circuit Engineering Association's PCB Chat at pcbchat.com and Ascendo Reliability at reliability.fm for syndicating the show. Thanks also for your questions and episode suggestions. Please keep them coming. I love to hear from you. Send comments or questions or episode suggestions to Mike at mikekonrad.com. Just remember that's Konrad spelled with a K. To learn more about the Reliability Matters podcast, please visit the Reliability Matters podcast website at, you guessed it, reliabilitymatterspodcast.com. Once again, thanks for listening or watching. Until next time, stay safe, stay healthy, stay happy, and perhaps most importantly, keep doing it right. I'll see you again in 2 weeks.
Thanks for listening to the Reliability Matters podcast. Join us on the second and fourth Tuesday of each month for new episodes of Reliability Matters.